Moving on to the fourth example for 2D projectile motion. We have a ball thrown into the air. We're not given any information about its initial velocity. We are told after 5 seconds the vertical velocity is 10 meters per second, and it has moved 20 meters horizontally from its starting point. Okay. We want to find how fast was it moving when thrown, which is a question of v naught x and v naught y, and how high is it above its starting point, so that is y. Okay. So drawing a picture. It is thrown up into the air with some velocity. We don't know what it is. We are told that 5 seconds later, it is now here. This is 20 meters from its starting point, so I propose that we let the initial position be 0, the final horizontal position be 20. We are also told that at this point, Vy is 10 meters per second. Now the way I have it drawn, it looks like it should be gone downward. However, it doesn't have a sign, and it doesn't say upward or downward. Given that the typical coordinate system has up as positive for y and right as positive for x, it is safe to assume that this actually means a 10 meters per second upward. So my drawing isn't 100% accurate. It still should be moving upward. That's okay. We also know acceleration due to gravity downward. Writing out the grocery list. So our final position is going to be 20 meters. Our initial position we defined as 0. We are not given any information about the horizontal velocities, so we have nothing we can put in there. We do know that we want to find v naught x as part of our answer. A sub x is 0, and we're told we're looking at 5 seconds, so t is 5. Y is one of the things we want to know, so I'm going to put a question mark. Why not? I'm going to choose to let be 0 meters. V naught y is one of the things I want to know. Vy is 10 meters per second, and again we're assuming upward, so I'm going to leave it positive. And ay is going to be a negative 10 meters per second squared. The next step is to write out our equations again, just so that we have them to refer to. I'm writing the wrong 1 second from what I've typically done, so I'm going to erase this really quick and start over on that equation. There we go. Now we got them down. Okay. I want to know v naught x, y, and v naught y. I have one equation that involves v naught x, and I know everything I could use to find that. So let's start there. X is 20, x naught is 0, v naught x is what I want to know, t is 5, because that's given in the problem, and a sub x is 0. Okay, so 20 equals V naught x times 5. So V naught x is 20 divided by 4, or 20 divided by 5, which is 4 meters per second. Okay, so now let's look at V naught y. I have two equations that involve V naught y, the middle one and the bottom one. However, if I look, the middle one also involves the vertical height, which I don't know. Therefore, I have to use the bottom equation to find V naught y. Honest, I don't want to do that. Okay. Vy, we're told in the problem, is 10 meters per second. V naught y is what I want to know. Ay is negative 10 meters per second squared, and t we found, or were given, was 5 seconds. So simplifying, 10 equals V naught y. 10 times 5 is 50, so minus 50. So V naught y will be 10 plus 50, which is 60 meters per second. Lastly, I want to find how high it is above its starting point, so that's a question of y. So I have to use the middle equation. Y naught we set to 0. V naught y we just calculated to be 60. We're going to multiply that by 5. And A sub y is 10. Okay, 60 times 5 is 300. 5 squared is 25. Times 10 is 250. Divided by 2 is 125. So that means that y equals 300 minus 125, which is 175 meters.